Hi everyone, and welcome back to another physics experiment. This week we are doing circular motion. We're going to be swinging a mass in a circle above our heads and measuring the time it takes to make one revolution. That is the period of the motion. To prepare for this experiment, we're going to need a couple of plastic bags filled with coins. We'll tie them together with a string, we'll thread it through a straw, and then make some markings on it to keep things all in the same location. Let's start with our rotating mass. We're going to put 3 nickels or 6 pennies into one of our plastic bags. Those will be the rotating mass. They will not change from trial to trial. 6 pennies or 3 nickels has a total mass of 15 grams or 0.015 kilograms. Once your masses are in your bags, I would recommend clipping them with a paper clip or tying it with a rubber band so that the excess plastic doesn't flap as it flies around in a circle. Then I would put a paper clip through the other corner so we can tie a string through it. Once that's attached, you'll lay it out flat, and we want to mark a distance of 1 meter from the coins, 1 meter from the rotating object. Using our meter stick, we can mark 1 meter, and we want to place a straw with the top of the straw at 1 meter, and then we'll mark below it as well, so that as we begin to rotate this object above our heads, we can watch the straw and the string's location to make sure that it doesn't slide up or down. Once you've threaded your straw with the string, you can then tie your hanging mass to the bottom of it. We will prepare the hanging mass by first placing 22 pennies or 11 nickels in a bag. That would have a mass of 55 grams or 0.055 kilograms. The hanging mass will provide tension that will be the centripetal force that makes our rotating object move in a circle. The goal is to spin this above our heads while making sure our mark stays above and below the straw, and using a stopwatch to time 10 revolutions. We're going to do 10 revolutions and then divide by 10 to get the average time for 1 revolution. So let's try this out. We're going to let our mass hang, and we're going to begin to spin the rotating object above our head. I should be able to let go of the hanging mass, and its centripetal force will provide the tension. If we spin too fast, the rope will slide up. If we spin too slow, the rope will slide down. So find that nice Goldilocks zone in between, and when you're ready, you can get your stopwatch out. I think I've found a nice rhythm here, so I can begin to time. Ready? 3, 2, 1, start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I stop after 10 revolutions, and I found my time to be 11.41 seconds. That is the time for 10 revolutions. I want to take the average, so I divide by 10 and I would get 1.141 seconds as the average time for 1 revolution. I would then add some more mass to my hanging mass. I would add 6 more pennies or 3 more nickels for 15 more grams. And we will repeat this experiment for 5 different trials. As usual, if you have any questions about this setup or any calculations, check in with your professor. But that's all for this week. See you guys next time.